I am Hyoshin from NC State University Department of Statistics, and I have been working with the master student Kate Sanborn and Professor Allison Wilson on this project called Risk Comparison and Planning for Bayesian Assurance Tests. Oh, I might scroll down. So in this project, we were interested in assessing the reliability of a system by doing a series of pass-fail tests. So we would like to know how many tests we should do in advance to be confident enough that the system is really reliable. So to put this more formally, we would like to select what's called a binomial test plan, where we select a tuple N and C, where N is the number of test units that we want to test, and C is the maximum number of failures allowed. And so if we observe fewer than C failures out of the N test units, then the system passes. And similarly, if we observe more than C failures out of the N test units, then the system would not pass. And there are many ways to choose a test plan N and C such that we can balance our risks and resources. So in this project, the specific questions we were interested in answering were these three you see on the screen, which is first, what are the specific risks that we want to control? And secondly, what are some of the commonly used methods for choosing a test plan N and C? And lastly, how will we compare across the different test plans that we found using the different methods when we're clearly controlling the different risks for each of the methods? So to answer the first question here, we introduce 7 risk metrics that you may want to control to choose a test plan N and C. And the first categories of categorizing the risk metrics is first is the classical risks, which are the metrics that make inference based on the pass-fail information we observe during our N tests. So these are the consumer's risk, CR, and the producer's risk, PR. And the second category we have here is the Bayesian risks, which are the risk metrics that make inference based on the pass-fail information that we will observe during our N tests. And also we use the relevant pass-fail data that we have observed from our previous tests. And so the 5 metrics that we introduce here are the assurance metric, the posterior consumer's risk, PCR, the posterior producer's risk, PPR, the effect size, and the average length criteria, the ALC. And to answer the second question we introduce 5 commonly used methods for choosing a test plan, N and C. And we have 2 methods that control the classical risk, which are the OC curve and the SBRT, which controls the consumer's risk and the producer's risk simultaneously. And we here have the 3 methods that control their own set of Bayesian risks. So we have the ARDT here, which is relatively new. It came out in last year, actually. It controls the assurance metric. And we have the Bayesian assurance metric, which method that controls the PCR and the PPR simultaneously. And we have the Bayesian power method, which controls either the effect size or the ALC criteria. And here is an example of how you would compare across the different methods. So here we have an example, a row from the table comparing the 5 methods. So if you look at the row for the Bayesian assurance we have right here, this method chooses a test plan that controls the risks PCR at 5% and PPR at 10%. And there can be a lot of candidates, the possible test plans N and C that would control both the PCR and PPR. And here we've chosen the test plan that gives us the smallest test number of tests N and the biggest maximum number of failures allowed C. That gives us the test plan 108 and 0. And when you're comparing the different test plans, I would like to point out that there really is no universally best method that controls all the 7 risks. But what you can do is, after you've chosen the test plan, you can calculate the 7 different risk metrics and see if the risk metrics actually are reasonable, they make sense. So in the slide right there, if you look at the Bayesian assurance and you look at the risk metrics that correspond to the Bayesian risks, you look at assurance that gives us a 44%. And for this particular data set, assurance of a more than 50% would be the ideal. But here we have 44%, and you could look at that and say, hey, it's close enough to 50% that we're happy with. And same for the effect size, it's 95%. And for this data set, something over 90% would be considered ideal. So it meets the criteria. And if you look at ALC, it gives us a 4.5%. And for this data set, if we have something below 3%, it would be ideal. But if you have 4.5%, that's close enough to 3%, then we can conclude that we're happy enough for this and settle on the 108 zero test plan that we've got using the Bayesian assurance. And so lastly, methods that control the Bayesian risks tend to give smaller test plans, and we can use additional relevant information that we've got from the previous tests into the planning, so that may be preferable to the decision maker. And so because of the time, I didn't include all the details about the different methods that we are comparing and what each of the risk metrics mean. So if you're interested, please come and check out the poster, and I'd be happy to take any questions. Thank you.